I'm gonna say hi to Ray. Hi, Ray.
Hi, Ray.
Hopefully you're feeling okay at home.
Miss you.
Yeah, we miss you, right?
Max misses you.
Yes, Max does. All right, here we go. Multiplying vectors by numbers geometrically. So what does that mean? If I'm going to give you, let's give you, by the way, because graphing vector does not matter, it doesn't matter where you start. Where would you normally start? At the origin. It's easy to count rise over run. For the sake of time, we are going to make a dot right here as your beginning. And I'm going to go up 2 and over 5. 2, 4, 5. This is a makeup one. So here's vector v. Okay. So we can totally multiply vectors. So first example, we're going to make up some. What if I want to take 2 and I multiply vector v? How would you graph that out? Geometrically. So if I said graph 2v, where would you start?
Anywhere.
Anywhere. Where would you start?
Towards the middle.
Towards the middle. Would that be okay? Where would you guys start? Yes, you can start anywhere you want. Okay. Now it's twice v. So now what do? Where would you end?
Up 4 to the right 10.
Up 4 to the right 10. Would you guys agree, Michael? Perfect. So if you start somewhere in the middle, you go up 4 to the right 10. If you start at the origin, you go up 4 and then 2, 4, 6, 8, 10. This is 2v. Okay. If you start somewhere in the middle, that's okay too. Wherever you like. 2, 4, 2, 4, 6, 8, 10. It's about here. So again, however or wherever you would like. Now, in the box it says, if alpha is a scalar and v is a vector, the scalar multiple of alpha times v is defined as follow. If alpha is a positive number greater than 0, alpha times v is the vector whose magnitude is, what's the magnitude of your 2v? What would you feel in that first blank space? How many times the original? 2. Well, so if we have an alpha, would you agree there's alpha times? Okay, alpha times the magnitude of your original v. And whose direction is the same as what? As your original vector v. If alpha is negative, which is less than 0, and alpha times v is a vector whose magnitude is what? It's alpha. But because alpha was negative, would you agree that it's absolute value of that? Because magnitude cannot be negative. Times the magnitude of your original vector called v. And whose direction is the same, opposite? Opposite. So I'm going to just try to squeeze this in. Opposite as your original vector v. So what does that mean? What if I give you another one? Instead of 2v, let's do negative 3v this time. And I'm going to ask you to graph that out. Where would you start?
Anywhere.
Anywhere. I'm going to, by the way, negative 3 times v is going to be quite long. So can I start here at the top?
Yeah.
Yeah. What direction are we going?
Down.
Down how much? 6. And then what after down? Over what direction? Left. But how much, by the way? 15. Woo. 2, 4, 6. This is 14, so would you agree that 15 is a little bit off the grid? This is right here. Negative 3v. So negative is going complete opposite of your positive direction. Okay. So some properties. So 3, if alpha is 0, could we talk about bigger than 0 and then less than 0? If alpha is 0, or if your magnitude, or if your vector, vector v is a 0 vector, then alpha times v equals 0. So if either one is 0 or both of them 0, then multiplying together will still be 0. Okay. So if 0 times vector v, and vector v does not have to be 0, then this becomes a 0 vector. If you have 1 times vector v, this is an identity property. 1 times anything is itself. It doesn't change anything. Negative 1 times vector v, it's just now negative direction of your original. If you have 2 scalars now, alpha and beta times vector v, you can distribute them. Okay, so you can say, okay, alpha times vector v plus beta, which is another different scalar, times vector v. If you have an alpha, which is a scalar, times 2 vectors, let's call these vector v and vector w. Yes, you can distribute those too. It's the same thing, saying alpha times vector v plus alpha times vector w. What if you have two scalar, a and b, and you times them by a vector v? Multiplication in vector, you can move them around if you like. Okay. What is the word that we use in mathematics when you can move things around? Commutative, right? Associative is actually another thing too. Associative is when you regroup the groups. So this is actually either, because I'm regrouping and I'm moving things around. Okay, ready? Add and subtract vectors algebraically. So geometrically, we can totally do it. Algebraically. Let v, vector v, be a subscript 1, I and j. What are I and j's again? You can see those so much. What's I? So, no, that's a different I altogether. This is a bold I. Looks like vector I. No, this is a bold vector I based on the printing. Yes, vector I. What is vector I? What direction is that going?
Any direction.
Any direction? Not necessarily. Not any direction. Vector I and vector j. Because it says here, vector v equals something in the I vector. Emma?
Would it just be the horizontal?
Yes. Okay. Vector I is the horizontal direction. Plus some vector j. Vector j is, guess what direction? Vertical. Then you get a vector v that goes in wherever those two add up to be. Okay. So I is always horizontal. It can be negative, that means go left, positive, go right. J, again, positive, negative. Positive goes up, and then negative goes down. Okay. So let vector v equals a subscript 1 I plus b subscript 1 j. Component-wise, you can write it algebraically as a1 comma b1. And giving you another vector, w, a2i plus b2j, component-wise, a2b2. Are two vectors, and let alpha be a scalar. Then, here we go. When we add the two vectors together algebraically, your final answer will be in the ai plus bj format. But what you do is you take a1, you add a2 in the I direction, that's horizontal direction, plus b1 plus b2 in the j direction. Okay. Now, in terms of writing it as a component, it's a1 plus a2, comma, b1 plus b2. You can do the same thing for subtraction. V, vector v, take away vector w. So in subtracting, you're just subtracting your components. I's first, plus b1 minus b2 in the j direction. So you can go a1 minus a2 and b1 minus b2. So subtracting the two vectors, all you do is taking the two components and subtract them. And it says alpha is a scalar, so when you guys multiply alpha to one of the vectors, all that is you take alpha times component of a subscript 1 in the I direction plus alpha times component of a subscript 2 in the j direction. It's the same thing as if we were to go alpha a1 comma alpha a2. Now, just to kind of refresh our memory, if I asked you to find the magnitude of V, how would you do that? What's the formula for the magnitude of V? We defined it already. So, remember, V is A subscript 1 I plus V subscript 1 J. So how do we find the magnitude? What's the formula? Magnitude formula. What do you think it is? I'm giving you a square root, so square root in there somewhere. Michael?
Square root of A1 minus A2 squared.
Square root of, remember, I'm only looking for V. So, absolute value of V. So A1, what? Wow, okay. You guys need to get up. We gotta wake up. What is the magnitude? This is so important. You can't go anywhere without knowing the magnitude. A1 blank. A1 what? Find the definition of magnitude for me, please.
Size or length of the vector.
Size or length of the vector, yep. What's the formula? First, can it be negative?
No.
No. So that's why we use an absolute value, right?
Greater than or equal to 0.
Emma?
Is it A squared plus B squared?
Yes, it is A squared plus B squared. Why is it A squared plus B squared? Should we go back to, all right,
It's like the Pythagorean theorem in the sense that it's the horizontal plus the vertical.
yes, isn't the same as the radius. Let me ask you that. Remember we connected to the radius? But isn't the radius r equals square root of x squared plus y squared? Zen? Huh? It is totally. We also went there. Remember we used a distance formula and we connected, and the reason x2 or one of the x's and one of the y's were gone is because one of the points were at the where? The origin. So that's why it was 0. So that's why it's all gone. Okay? Perfect. Now, next formula. Find a vector from its direction and magnitude. What this means is I'm going to give you the direction. I'm going to give you the magnitude. Your job is to give me the vector. So here's a vector, V. Vector V equals, if I give you the magnitude, then you just put it in the front. So whatever the magnitude I give you. Then times cosine. If I give you direction, it's normally in the form of an angle. If I give you 30 degrees, do you know what direction that is? Yeah, you're going to go counterclockwise. If I give you 110, you would go to quadrant number 2. So normally your direction is in the format of what? An angle. Okay. So cosine of whatever angle I give you, alpha, theta, beta, okay, and in the I direction, plus sine of theta in the j direction. And where theta is the direction angle between vector V and vector I. And this is where I want to clear out or clear up your I and J and what that even meant, okay? So I just mentioned I and j. And normally, if you can see this, can you see that most of your vector format is written in this way? See that right there? Something I plus something j. And I and j's are both, according to your book, they're bold. So I is going this direction. Okay, so this is an I vector. That's an I vector. I'm going to, let's make this 1 unit because it's easier just to do 1 unit. Okay, so this is 1 unit. I'm going to add that to vector j. How do I add vector j? Where would I start j and where would I end j? How do you add vectors? That's right, you're going to continue at the end. We talk about j being vertical. So we're going to deal with positive ones now. So we're going to go up j. So when we go up, okay, let's say here, I'm going to go up. This is a vector j. Now vector v equal to something I plus something j. So that's why vector v starts here and ends there. This is vector v. Now, it says here theta, where theta is the direction angle between vector v and what vector? I. Well, then would you agree that this is theta right here? That's what it meant. So this is your directional angle. Okay. Now let's talk about why do they have cosine here and sine here in the formula? Where do you think cosine comes from? Where would you need cosine, Chris? What do you think?
Cosine to find the x magnitude.
Yeah. Wouldn't you agree that I would need to use cosine to find this piece of length? Because cosine is adjacent over hypotenuse. But if this is a unit circle, do I need to worry about the hypotenuse? No, because everything is resort back to the most basic, which is the unit circle. So that's why this is cosine, and cosine always goes horizontally. And then this is why this is sine, because sine is opposite over hypotenuse. Is a unit circle, hypotenuse is what? 1, right? So that's why we don't need to worry about it. And then if it's not, that's why this magnitude comes in. This magnitude represents something that's not what? 1. Okay. So that's why the i's and j's are in. All right, directional angle. We restrict it to be only between 0 degrees and 360 degrees, or 0 to 2 pi, non-inclusive of 2 pi. Now, we always have to find your angle in application. Like if you apply it, or a captain, and you have to find the direction that you're going. How do you find your directional angle? What formula should we use? Theta equals what? Theta equals tangent. Tangent what? Tangent inverse of y divided by x. What are y and x? Yeah, those are the components in front of I and j. Okay. So now, is that going to work for all quadrants? No, that will work for what 2 quadrants? 1 and 4. So you have to be very cautious of what? Check for the correct quads. Check for the correct quadrants. Okay. So if you need to get to quad 2, then make sure you add something. If you need to get back to quad 4, make sure you add the correct number. Oh, that's the end of all the definitions. Now let's go and do some examples. That honestly is like the longest set of definitions I've ever seen. So intense. This is why physics is so difficult. Okay. Right, example 1. Can you help me with the instruction, please, Emily?
Use the given vectors below to graph A, U minus B, plus.
Perfect. So I'm giving you some vectors here on the grid. For the sake of consistency, let's put the starting dot here and an end dot right there. Starting dot here and end dot here. Just so that way we can all talk about the same measurement, okay? So it says, use the given vectors below to graph. Okay, I'm looking for an answer of u, take away 2v plus a w. Since I did not make a grid for you, we had to make our own grid. Look at that. Okay. Where would you like to start? What's the easiest starting position? Yeah, at the origin. So you're going to start graphing vector u first, and we will start at the origin. Okay? Vector u has what direction and what length? How do we graph vector u? Go where? Down how much? 3. And then to the right how much? 3. So 1, 2, 3, 1, 2, 3, make a dot. So this is vector u. Okay, then we need to graph out negative 2v. What is 1v in the first place? What's the magnitude of that? 3 units to the right? What's 2v? 6, but it's negative. Go the other way, you're right. Where do we start? Can I start back at the origin?
No.
No, you need to continue where your last dot was. So we are gonna go 6 units to the left, okay? So this right here, class, is negative 2v. That's just adding the first 2 pieces. Now we need to add what? Oh man, what's the size of W? What is that? Up how much? 7, right? How much? 7. So you're gonna go up 7 and right 7 from the origin again?
No.
No, at the end of that last dot, okay? 1, 2, 3, 4, 5. Okay, so I need to count. Up 7. And then 3, 4, 5. So right here is my. Okay. That is your W vector. Well, I need to find the answer. I did all the hard work. How do you guys write your final answer for vector?
You draw a vector from there's the origin, the start point, you're finished.
Yes. You draw it from your start point to your end point. So the ending location has to be the same as the where you stop, and the starting has to be the same. So the final answer, looks like I'm somewhat over the same line there. If I graphed it correctly, it shouldn't be, but since I'm making my own grid and everything, it's a little bit off. So this right here, it's my starting, and this is my ending. So this is my final answer. Okay. Again, it has to be the same dot, but can you guys see this kind of overlapping a little bit? So that's why I'm putting it slightly below. But technically, it should be the same exact ending dot. Okay. I'm gonna give you a heads up. A lot of you will do all the work. And guess what you would do? You would forget the answer. Okay, so don't forget, Michael.
So for the very final answer,
Yeah.
we don't have vectors u, w, and 2v. It's still correct as long as we have that final one. Or do you want us to include on the other one?
Are you talking about like all 3 vectors?
Yes.
If you don't have it, if you know already, Michael, that the final answer is just from here to here, you can just go straight. Does that make sense? See what Michael said? Yeah. All right, why don't you guys try out B to see what you guys come up with. Alex, why? What's your starting location, hun? You want to start in quad 4? Somewhere in quad 4? Okay. Where do you want me to start in quad 4? What do you have in your notes?
I didn't do it yet.
Okay, I'll wait for you. I don't want to move too fast. Hannah, what did you start? The origin, okay. Alex, why don't you talk to Michael and then compare your answers? Okay, so Alex, what do you want to start in quad 4? Or would you like to change your mind?
I'll start in
Where's your ending dot?
9 and 7 down.
Okay. Much better, right? Okay. Technically, yes, you can start anywhere, but you would need a lot more space then in quad 4. All right, let's move on. Example 2. Can you, Grace, help me read the instruction for example 2?
The vector v has initial point p and terminal point q. Write v in the form of ai plus bj. That is, find its position vector.
Perfect. It wants you to write v in this format, and that's the same thing as finding the position vector. So to find the position vector v, the formula says take x2 minus x1 and take y2 minus y1. Do we know what x2 is?
Yes.
Yeah. What is x2, Evan?
What? Oh, -6.
Good. What's x1? Caitlin? Y2, Zen. Good. Take away Riley. -2. All right, let's see. So the components come out to be -9 comma what? -3. Do you think it wants in that form? No, it does not. So it wants an AI. What's your A value then? -9 in the I direction plus -3 in the J direction. Technically, guys, can I just write -9i minus 3j? Yep, both are acceptable. Okay, try B on your own. Let me know. Now on your homework, or when you're taking notes, make sure you write the formula down so by the time you get to next week and take your test, it's already where it's supposed to be. So I'm looking for just the final answer. So Tim, you are whenever you're ready. There's no rush, but whenever you're ready, give me the final answer.
Vector v is equal to 3
I?
3i plus 3j.
Perfect. When you read 3i and j, we know those are vectors. Who disagree with Tim? Okay. Dana, can you help me read the directions to example 3?
Find write the v given v equals negative 2I.
Perfect. Okay, let's write down the formula. What is the formula for the magnitude, Max? Rad? Plus b squared. Good. Okay. Or rad x squared plus y squared. They're exactly the same thing. Joe, what's your a value and what's your b value?
The a value is -2 and the b value is 12.
Perfect. So under the radical, -2 squared would be what? 4. And then 12 squared would be what, Joe?
144.
Good. So this is square root of 148. Should I box that up or can I simplify? Simplify. 148 is 4 times what? A big number. 37. So if I don't have a calculator, it's just 2 rad 37. And leave your answer in exact form. It's just a lot easier to do with. Example 4. Dean, help me with the direction, please.
Find v subtract one w given v equals -2I plus 12j and w equals 2I plus 3.
Perfect. So that's red. Find the magnitude of v, take away the magnitude of w. Okay. Would you guys agree that your vector v is the same as example 3?
Yeah.
Which means you already know what?
It's 2 vectors.
The magnitude. So now your job is to find the magnitude of what?
W.
W. All right. So find the magnitude of w. Go ahead and get going. Quinn, whenever you are ready, just give me the magnitude of w. Rad 13. Beautiful. Good job. So now, rad 13. Now we just have to put those together, right? Okay, rad 13. So magnitude of v, take away magnitude of w, equals 2 rad 37. Take away rad 13. Can I simplify those? Nope. And that means I can box it up. See, the applications themselves are not bad. It's just like the behind, concept. See, look, can you help me read the instructions for example 5, please? Thank you. Find the unit vector. What is the definition of unit vector? We have to write that down. Unit vector equals. What's the definition?
Magnitude is 1 unit.
It is, but what's the formula? Because I need to find it. Tim.
Vector u is equal to v over the magnitude.
Equals to vector v divided by the magnitude of what? V. You're right. Okay. Well, if you look at the example, is this v the same as example 3? That means we should already know what?
Magnitude.
The magnitude. So now we just have to find the unit vector. So unit vector equals vector v, which is negative 2i plus 12j divided by, what's the magnitude? That's right, 2 rad 37. No, you may not leave it like that. You have to break it up and make it pretty. Okay, so vector u equals negative 2 divided by 2 rad 37. And again, if you see that I'm writing a lot and you don't need all of these details, and you can write whatever you need, okay? 2 divided by 2 rad 37 in the j direction. I have to simplify that further. Can I reduce the negative 2 and the positive 2 in the I direction? Can I reduce this 12 and the 2 in the j direction?
Yeah.
Yep. So u equals negative 1 divided by rad 37 I plus 6 divided by 37 j. And no, you can't have radical on the bottom. So final answer. Unit vector is, what's your unit vector? Negative, what? Rad 37 divided by 37i plus 6 rad 37 divided by 37 j. Now, Evan had just mentioned that unit vector, guys, has a magnitude of how much? 1. Now, look at your components. Don't they look scary? It's like negative rad 37, negative 37, and then 6 rad. How is that going to give you a magnitude of 1? Do you think that's going to give you the magnitude of 1? Should we check to make sure we do it right? It's okay. Well, I'm going to write it now. You just have to bust out your calculator. I don't need you to do it manually because that's just an ugly number. Would you agree that for us to calculate the magnitude, all I got to do is a squared plus b squared and then the radical? All right, here we go. Hey, listen, don't trust your book or your teacher. You got to verify there. All right, negative 37 divided by 37 squared. Yes or no? Plus 6 rad 37 divided by 37 and then square. All right, check it for me. Is it coming out to be 1? Because that's the definition. If it's not, we did something wrong. Did you do our basic math right? Are we close? Did we do it right?
Yes.
Are we all? We did it right? Yes, so that's how we check. Make sure the magnitude is 1. Let's carry on. Next example. Whew. Let's move to quiz E. Help me read the instruction to example 6, please.
Write the vector v in the form ai plus bj given its magnitude v and the equal alpha that makes it the positive x-axis.
Perfect. So you are asked to write a vector. You are given a magnitude and also an angle. I just gave you that formula today. How do we write a vector if a directional angle is given along with the magnitude? What's the formula say? Vector v equals, what's the formula? Perfect. Good job. Did it give you magnitude?
Yes.
Yes. What is the magnitude?
Same.
Beautiful. Cosine. Did it give you alpha or theta or beta? An angle. What's the angle that they gave you? 30. Perfect. Plus sine of 30. No, you may not leave it like that because it doesn't want it like that. How does it want? In the form of AI plus BJ. How do I get A and B? Simplify. Yep. Cosine of 30 is? Rad 3 over 2. Yep, basic trick will always come back. Sine of 30 is straight up. Half. Simplify some more so we can box it up. 6 times rad 3 divided by 2 will give us 3 rad 3 in the I direction plus 3 in the J direction. When possible, leave it in the exact form. Okay? Why don't you try B and let me know what your final answer is. And I think that's probably all the time we have today after the B. So tonight's homework, I'll be recording example 7 and 8 at the end of our project. I have lunch tutorial today because it's Tuesday. I don't have anything else to do. What's cosine 315? I like multiply over 4, you know, over 45 degrees. These type of questions will definitely know the non-calc, so we have to know the basic unit circle really well. Once you guys have a final vector v, can you just compare your answers with one another? And then Ruby, whenever you feel like you're ready to give me an answer, go ahead and throw it at me. -7, Brad 2, Jace. Confirm or deny, guys? Confirm. All right. Everyone say goodbye to Ray.
Bye, Ray. Miss you.